So in this video, we're going to discuss the discriminant, and the discriminant is a piece of the quadratic formula. So right here we have the quadratic formula. We know we use the quadratic formula when we are solving a quadratic equation that is of the form ax squared plus bx plus c equals 0. And this is what generates our solutions. Remember, this is the end process of completing the square with a, b, and c. Instead of having specific values for those coefficients in constant term. Now, the discriminant is just the expression under the radical, okay? That's called the radicand, the expression under the radical. So b squared minus 4ac is called the discriminant. It's just a part of the quadratic formula. And the reason why someone gave it a specific name is because if you know the value of the discriminant, okay, it describes for you the number and type of solutions you will have. Now, another name for solutions is going to be roots. Roots is when you're talking about it in terms of a function. Solutions is when you're talking about it in terms of an equation equals 0. Roots is when you're talking about setting a function equal to 0. But when you're talking about, just to talk about this now, when you're talking about solutions, roots, X-Intercepts, they all have something to do with each other. Solutions are when you solve and you have it set equal to 0. The solutions are the values of x that make the left equal 0. Your roots are when you take a quadratic function and you were to find when is the output 0. That's called finding its roots, okay? That's the same thing as now you're solving. And the X-Intercepts, remember, are the values of x that give you an output of 0. X-Intercepts are the graphical chunk, but the X-Intercepts have to only be real, okay? You can't plot some things that are not real, okay? But just so if you ever hear this, solutions, roots, okay, they're basically same thing. They're just talking about different pieces, the quadratic equation, the function, a chunk of the graph, okay? So we're going to go through, and based on what the discriminant is, you can describe the type and number of solutions you're going to get before you even finish simplifying what the solutions are. So here are the 3 problems that we're going to do, okay? So remember, the discriminant is that b squared minus 4ac. So I'm actually going to solve. We're going to talk about it. Okay, so number 1 is 3x squared plus 5x minus 1 equals 0. So if I solve this equation, okay, x equals negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 1 all over 2 times 3. So that's going to be negative 5 plus or minus the square root of. And now this 5 squared minus 4 times 3 times negative 1, that's the discriminant. So right now, you should be getting the value of the discriminant. 25 plus 12, that's going to be 37 over 6. Now, what this tells me, the fact that the discriminant is positive 37 tells me that my answers are real. Okay? They're real because the square root of 37 exists. It's a real number. Now, if I were to break this up, this is going to be negative 5 plus the square root of 37 over 6 and negative 5 minus the square root of 37 over 6. These are going to be 2 different values. So this gives me 2 real solutions. They're also going to be irrational because 37 is not a perfect square. But I know that because my discriminant is 37, I know my answers are real and that I'm going to have 2 of them. In number 2, we have 4x squared plus 4x plus 1 equals 0. So it's negative 4 plus or minus the square root of 4 squared minus 4 times 1 all over 2 times 4. So that's going to be negative 4 plus or minus the square root of, and now we get our discriminant value. So that's going to be 0 all over 8. So what this is, if I simplify this, the square root of 0 is 0. So this is going to be negative 4 plus 0 over 8 and negative 4 minus 0 over 8. Negative 4 plus 0 is just negative 4 over 8. Negative 4 minus 0 is still negative 4 over 8. You get the same answer twice. So you only get one unique answer. And it's real. This is not non-real. The only non-real is if you have a negative under the square root. Because the discriminant is 0, you know that your answers are real. So you get one real, and by one we mean unique, okay? That unique, we're really generating 2. It's just that it's the same number twice. One real solution because the discriminant was 0. And the last problem, x squared plus x plus 2 equals 0. So we do this. So this is going to be x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2 times 1. So it's going to be negative 1 plus or minus the square root of 1 minus 8, that's going to be negative 7 over 2 times 1. So the discriminant is negative 7 here, okay? The discriminant is negative 7, not the square root of negative 7. It's negative 7. So because the discriminant is negative 7, our answers are, part of it includes a square root of a negative number. So this means that there are no real solutions. Okay, when I ask you to state the discriminant, you do not take the square root. You just figure out what this is. Whatever this value is, that is the value of your discriminant. Okay, so just a little chart. And then that's it for discriminant. Okay, so we're going to make a chart, okay, and there's going to be 3 parts to it. Okay. So when the discriminant, so when b squared minus 4ac, when you take that value, when it is greater than 0, when the discriminant is greater than 0, you will have 2 real solutions. So let's write that down. You will have 2 real solutions, okay? So if you solve for ax squared plus bx plus c equals 0, and you just look at the discriminant, and the discriminant is greater than 0, you will have 2 real solutions. Graphically, what that means is, if you get 2 real solutions, if you were to graph ax squared plus bx plus c, if you get 2 real solutions, that means that you have 2 x-intercepts. You don't know where the x-intercepts are yet until you completely solve, but it means you have 2 x-intercepts. If the discriminant, when you were solving for ax squared plus bx plus c, if the discriminant equals 0, you only have 1 real solution. And how would that translate to a graph? It would mean you only have 1 x-intercept. Remember, an x-intercept is the value of x when the output is 0. If you are solving a quadratic equation that's in standard form, you are solving for when x, what makes x, okay, what can you plug in for x so that the output is 0? And lastly, if b squared minus 4ac is less than 0, you will have no real solutions. Graphically, if you tried to find the values of x when the output was 0 and you got only non-reals, what that means is your quadratic has no x-intercepts. So how can that happen? Well, if it's a u facing up and the vertex is already above the x-axis, then you have no x-intercepts. Or if it was a u facing down and the vertex was already below, you'd have no x-intercepts. But the discriminant is just the value of b squared minus 4ac, and it can just tell you about the number and type of solutions you have.